Next topic is endochondral ossification. As the name implies, it happens within cartilage, hence the name endochondral ossification. It occurs in most of your bones, not the flat bones that we talked about before, but certainly all of your long bones. And it begins with hyaline cartilage. So I want to go back to this fetal skeleton and say, okay, now we're going to make a long bone. Any of the long bones are associated with the appendages, so we could make any one, but let's go ahead and make the one that this is making. Can anybody recognize this bone here? This is this bone. This is a humerus. So we're going to make a humerus, which is one of the long bones. How does this process occur? Well, it starts with a teeny tiny little fetal hyaline cartilage model that is covered by perichondrium. The first thing that happens is the perichondrium gets converted into periosteum. Periosteum is useful for this process because, of course, it has the osteoblast, osteoclast, and osteoprogenitor cells in the inner cellular layer. So once you have the osteoblast, osteoclast, and osteoprogenitor cells, you can start to develop bone around the outside first. Notice that it actually happens first in this figure around the diaphysis or the shaft. That's where you first start making bone. That also is confirmed here because if you look at the long bones, notice that the diaphyses are ossified much, much earlier than the epiphyses. Okay, so I'm going to convert this to periosteum, and then I'm going to start making a bone collar. But which type of bone is easier to make? Spongy bone or compact? Which one requires the fewest resources, proteins and calcium? Spongy bone isn't as massive, so even though this isn't going to end up being spongy bone, we're going to make spongy bone first. So we're going to make a spongy bone collar around the outside. Okay, so I've formed this bone collar around the outside, and then sort of overlapping with these, they're presented as individual steps, but there's a lot of overlap. Overlapping with that, I'm also going to migrate some blood vessels into the middle of the diaphysis. And when I do that, I am actually going to bring osteoblasts, osteoclasts, and osteoprogenitor cells. So what's going to happen in here is the cartilage matrix can degenerate. You can leave behind the collagen fibers, and you can use those collagen fibers to start to form bone in the center of the diaphysis. This bone in the center, not around the outside, is called the primary ossification center. We had an ossification center in intramembranous ossification as well, but we didn't have two, so we only had one that would start from the middle and go out. In building a long bone, we're going to have two. So the primary ossification center occurs here. And I'm going to start doing exactly what you think I would do. I'm going to start making bone, the easiest kind of bone first. I can do it because I've migrated osteoblast, osteoclast, and osteoprogenitor cells in there. So I'm going to make spongy bone throughout the center of the diaphysis. Now I know and you know that spongy bone won't stay there, but think of it as sort of the scaffoldings for what's going to go later. So I'm going to make a spongy bone middle, okay? And then sort of overlapping with that, I'm going to start working on the ends, the epiphyses, okay? The epiphyses are right here, and they were still cartilaginous. So now I'm going to migrate blood vessels into the epiphyses. And with them, I'm going to bring osteoblast, osteoclast, and osteoprogenitor cells. And then I'm going to start to make the easiest type of bone tissue first, which is, of course, spongy bone. These two collectively are called the secondary ossification centers, not secondary and tertiary because they happen at the same time. So I'm going to start to ossify my epiphyses. Okay. Later on, I will remodel those. Okay, so now what I'm going to have is right here. At this point right here, from here to here is kind of what it looks like from infancy to like age 2. When a baby is born, the epiphyses, now this isn't full term, but it's pretty close. The epiphyses are not very ossified. They're still really cartilaginous. It's part of the reason that babies are so bendy. So by about year 2, you're going to have done most of the remodeling that's necessary to make your bone look quite a bit like an adult bone, with one notable exception. So during the first 2 years of life, you really work on the epiphyses. And then the remodeling is going to be going on, and the remodeling will basically say, okay, where do I need spongy bone? Where do I need compact bone? Where do I need a medullary cavity? So what's going to happen with remodeling is in the diaphysis, the spongy bone is going to be scooped out of the middle using what kind of cell do you think? Osteoblast, osteoclast, or osteoprogenitor cell? Yeah, you can use osteoclast to scoop those out, and then you'll make yourself a medullary cavity. And you can remodel the spongy bone collar into compact bone with osteoblast, osteoclast, and osteoprogenitor cells, which are part of the periosteum. And the ends here started out as spongy bone, and you're going to leave them mostly spongy bone, but you're certainly going to remodel them into compact bone at the edges. Okay, the ends of the bone, though, were cartilage in the beginning, and they're still cartilage. The ends of the bone is still articular cartilage. And remember, articular isn't the type of tissue. It's sort of the function or location. So it was hyaline cartilage and it never ossified, and now it's still hyaline cartilage. It's called articular cartilage because it's used for forming joints. Okay, so the cartilage model, this here, so now really the only places that I have cartilage left behind is the articular cartilage at the ends, 1, 2, at the proximal and distal epiphyses. And then I've still got a plate of cartilage that's left behind because I ossified the diaphysis and I ossified the epiphyses, but they hadn't met yet. So I've now got 2 little cartilage plates, one on each end, the proximal and distal. Those are called epiphyseal plates. And the epiphyseal plates are going to stay cartilaginous until growth, long bone growth, is complete, which happens after puberty. So we will talk about long bone growth in just a minute. So the epiphyseal plates will eventually seal to become epiphyseal lines, which will happen at adulthood. So basically you're going to be like this structure right here until after puberty, and then eventually it will seal so that there's only an epiphyseal line and it's all bone. Come on. Now I'm trying to show you the picture. I won't show you. When your epiphyseal plates are still open, if the bone is dried, the epiphysis will fall off from the diaphysis as the cartilage degenerates. And this is kind of what it looks like in a histological slide. So this is a subadult. This person, this bone was not finished growing yet. Okay, so last little tidbit for this one is to talk about bone growth and length, since we're already at this picture. So how does bone growth and length occur? Bone growth and length for instance, a humerus or a femur or something. So you're kind of like this, not drawn to scale, but you're kind of like this from age 5 until you hit puberty. And then what happens is You're continually making new cartilage at the epiphyseal plates. So you're continually adding cartilage. So imagine that I've got the proximal epiphysis and the distal epiphysis. You're continually adding cartilage, but then you're ossifying behind it, adding cartilage and ossifying behind it, adding cartilage and ossifying behind it. And since you're doing that, the ossification is chasing cartilage growth and lengthening the bone. But if the ossification and the cartilage growth are occurring at the same rate at an epiphyseal plate, then the thickness of the plate will stay relatively constant. So if you have a little cartilage growth and a little ossification, a little cartilage growth and a little ossification, then the epiphyseal plate stays consistent. Bone lengthens on average about 2 to 3 inches per year. And it will stop when your epiphyseal plates seal, which happens on average age 18 in females and age 21 in males. But that's variable. Some people grow up to 23 and some people stop growing at age 15. Those are just averages. And so why? Why does it stop growing? Well, the reason it grows at all is, of course, adequate diet, right? You've got to have calcium and protein, vitamin D for calcium absorption, vitamin C and zinc primarily for cell division. But you also have to have some hormones, not sex hormones yet. Growth hormone and thyroid hormone, those are all necessary for growth of all tissues, including bone. But your sex hormones, when you hit puberty, they actually speed the process up. What they do is they speed up both cartilage growth and ossification, but not at the same rate. So what will happen is you've got this plate and it's this thick, right? And then your sex hormones come on in, okay? What it will do is it will speed up both ossification, both cartilage growth and ossification, but it'll speed up ossification a little bit more. So the plate thins and the plate thins and the plate thins, and then the plate seals. And it is the sex hormone surge that eventually causes your growth plates to seal, and your epiphyseal plates will become the epiphyseal lines. Now, you've been a human, so you know that generally speaking, puberty happens a little earlier in most women, and they grow earlier, but they do not grow as much, typically. So estrogen comes on earlier and actually does not cause as much bone growth and length as does testosterone that comes on a little later. And it's not just estrogen and testosterone, but we'll simplify it to that. So the male sex hormones come on a little later. Males grow a little longer, and typically speaking, males also get a little taller. Okay, so yeah, we'll stop there.